everyone, this is Mel. Today, let's go through Chapter 2, Reviewing Coordinate Geometry. And this is about the expression of a line, of straight line. Okay, first, the midpoint. So, the midpoint of a line segment joining the point x1, y1, and the point x2, y2 is with this coordinate. So why is that? For example, let's say this is x1, y1, and here we have x2, y2. So this red line segment, we want the midpoint, so clearly it's here. For the x coordinate, when we want the midpoint of something, we want the midpoint for the x coordinate, then it should be the sum of them and divided by 2. And same for y. We have y1 plus y2 divided by 2. And this is the general form of the midpoint, joining 2 points. And what about the distance? The distance between 2 points, A and B. A and B. So this distance, we can use the Pythagorean theorem, which is the long side square is equal to, so the AC square plus BC square is equal to AB square. Which for AC square, we have y2 minus y1. For BC, we have x2 minus x1. So this is equal to AB square. And if you want to find AB, the long side AB, you just take the square root of this whole. So you'll get AB, which is this formula over here. So this is by Pythagorean theorem. Okay, the gradient. So for the gradient is defined by the change in y over the change in x. So from point A, if we're going up to point B, the change in y will be y2 minus y1, and the change in x will be x2 minus x1. So it's very important to note that the order of the point you're taking. So if you use y2 minus y1, then on the denominator, you should also use x2 minus x1. On the other hand, you can also do y1 minus y2 and x1 minus x2. So it's very important about the order. You have to make sure you're keeping track of the order. Okay, this is defined as the gradient. So for a line with gradient m, the angle of the slope. So what does it mean by the angle of the slope? For example, this red line, the angle makes with the x-axis is the angle of the slope. So m is equal to tangent theta. So we already know that m is defined by delta y on delta x. And in a triangle, tangent, if let's say tangent theta, is also defined by this side, let's say side A on side B. So tangent theta is equal to A on B. And in this case, our A is just delta y, because the change in y represents the side, the vertical line side. So, and the change in x, delta x, is represented by the horizontal side, this one. So that's why the gradient is the same as the angle of the slope. And theta is the angle makes with the positive direction of the x-axis, so here. The gradient intercept form have equation like this. So we have the gradient m, which if we have y equal to mx, is something like this. So it crosses through 0.0. And if we have a plus c. So if c is positive, then the whole line will move up by c unit. If it's negative, then move down by c units. And that represents all the possible line we can have, straight line we can have. Or if your m, this is for m is greater than 0, so m to be positive, the line is increasing. M to be negative, the line is decreasing. M smaller than 0. Okay. So another way to represent the line, another expression, will be like this. So this is actually coming from the gradient definition. So m is equal to delta y on delta x. So for any point, if we know already a point A, which is xy, y1, and any other point along the line other than point A, we call it P with x, y. So the gradient can be defined for any x minus x1, which shows the delta x. Oh, sorry, this should be on the denominator. For any y on the point, minus y1 shows delta y, and any point x minus x1 shows delta x. So these are corresponding points, coordinates. And if we rearrange, we put the denominator to the left-hand side, which becomes x minus x1. Right-hand side is left with y. So now it's in the form of y equal to mx. Okay. This one is pretty similar as this one. However, we specify a point, the point xy, to be the point B, x2, y2. And then we can find the specific gradient. So m is a specific value. If we have 2 points, A and B, we can find m to be a specific value. And with this value, we can write a general form plus y1. So this is a general form of the line equation. So now the last point, if two straight lines are perpendicular, so we have a red line and another purple line. So if they are perpendicular, that means their gradient, the multiplication of their gradient is equal to -1. So for example, we can have this to be half, and this, the purple curve, should have a -2 gradient to make it as a -1. Okay, that's it for today. Thanks for listening. This is Chapter 2 of VCE Math Method, Unit 1 and 2.